My guest is Dr. Hagai Bergman. He's a doctor at the Hebrew University and president of the International Ganglia, Basal Ganglia Society. We'll have to ask you what that means because people won't know, I'm sure.
The basal ganglia are a small part of the brain.
Which part?
They are located inside. This is the reason we call them the basal ganglia. So we call them the basal ganglia because, like the basement, they are somewhere down in the dark part of the brain. This is a collection of neurons or cells that create our thinking or nerve cell. And the reason that we are mainly interested in this small collection of neurons in the basement of the brain, the basal ganglia, because when the basal ganglia are not working, we get many diseases. The most common one is Parkinson's disease.
Which is what we're going to talk about.
But
I want to go back into your history. How did you get, you got a medical degree and you did research as a scientist. How did you choose between being a doctor, a practitioner full-time, and being a scientist?
So actually, this was a conflict that I was fighting with myself for many years. I started medical school. After 3 years in the medical school, I've created my MD PhD program because at that time there was no MD PhD program. It was 73. And I switched to do my master and PhD thesis in parallel with my medical doctor studies.
Oh, I see.
When I finished my medical doctor study, I started the internship in parallel with postdoc. And all over my life, actually, I'm having this kind of conflict running few days in the lab, few days in the hospital. This day, I'm very lucky. One day, I'm in the surgery room, and other 5 days, I am in the lab. But this ongoing conflict is actually part of my life. I'm used to it. And meanwhile, I'm doing quite well with it.
Which means you'd have 2 jobs, in effect, as you say, 5 days in the lab and 1 day in the hospital.
Well, I'm having 4 jobs. I'm supposed to be a father and part of the family. So
yeah, yes. You have 4 children, too.
I have 4 children.
And one is in medical school?
The second daughter is in the medical school, and she's in this medical school. She just started the first year, and this is really great fun to meet her in the corridors of the medical school.
A real thrill,
yeah.
And your other 3?
And the oldest one is still in the army. Is in the Israeli elite unit of the Navy. Then the third one is also in the army. In the parachute,
He's a paratrooper?
Yeah.
Well, I have a grandson who's a paratrooper, so
maybe they know each other. And the small baby, she's finishing high school this day, and will go to the army next October.
Okay, let's go back to your basal ganglia. How did you get interested in the basal ganglia?
So again, for me, the basal ganglia are a source of most of what we do in our practical life. Because we can do 2 things. One, you can learn, if I tell you 1 and 1 plus 1 is 2, then it is very clear. You remember the fact. This is not interesting learning. The more interesting learning is what we call the procedural learning. How do you learn to ride your bikes? How you learn to walk? How you learn to speak? All this kind of learning that I cannot tell you what is the proper way to do it. You have to learn it by interaction with the environment and by getting feedback which is not complete. The environment does not give you complete feedback. It just tells you you are doing well or you are not doing well. And this is what the basal ganglia are doing. And therefore, for me, as someone that is interested in learning, in the brain, in the mind, the basal ganglia was actually the point of interest.
If I would have known that when I was a kid, when I was a kid learning to drive a bike and I drove it into the side of a truck and broke my tooth in half, I could blame my basal ganglia.
You can blame your basal ganglia, but eventually, actually, what we blame today, the basal ganglia, is mainly for the positive learning. Okay, so you learn better from positive reinforcement than for negative reinforcement. And the basal ganglia are part of the positive reinforcement learning device.
Okay, when I've read a couple of your papers, the part of it was motor controls, like bicycle riding, and Parkinson's is, of course, a failure in motor control. And we'll talk about that failure. But I want to get into, I didn't know about decision theory, so I want to discuss that. But let's do the basics of motor control. What goes wrong in Parkinson's that you begin to lose your control?
So in Parkinson, again, you can speak about two levels, what is going wrong in Parkinson. The first level is very mechanistic. We lose a group of cells that are located in the midbrain, and these cells are the cells that create dopamine, the neurotransmitter dopamine, which is used in the basal ganglia. This is the mechanistic point of view of what is going wrong in the basal ganglia. From the other point of view, what we are losing now is the ability of the basal ganglia to use the incoming information from the outside, from the internal part of the body, in order to make decision which action to do.
So it is always decision theory.
It is always a decision theory. Because all your life, what we are doing is that you are collecting information from the outside environment and from the internal environment, your motivation, your internal thinking, and then you decide what action you have to do. When we lose our dopamine system and the normal function of the basal ganglia, we lose the ability to create the next action, and the patient becomes akinetic. The patient is sitting like this, and this is the most severe problem of the Parkinsonian patient. The akinesia, the poverty of movement, the loss of the will to make action in the future. We see the tremor, but the tremor is a kind of compensation for this, because the patient is trying to use other system in order to compensate for the abnormal basal ganglia. So from our point of view now, as researcher of the basal ganglia and Parkinson's disease, the core symptoms of the disease is the akinesia, the loss of the ability to make action.
Yeah, but this, if you say we're taking in data, we're making decisions, it's a will, and you have to have the will to make those decisions, and then you have the outcome of the action. Now, why does will come into it? Why, I don't think of basal ganglia associated with will.
From my point of view, as a brain researcher, will is part of the things that the brain creates. From my point of view, there is, I don't agree with the distinction between brain and mind. Mind is what we feel are the function of the brain. So what we call the will actually is some kind of introspect understanding of the decisions that we have done. From my point of view, it is automatic, it is done by the basal ganglia, and then we put on it the title of internal will, self-will. But for me, this is what the basal ganglia do. And this is what our patients are losing. The patients are losing the ability to have spontaneous activity. And therefore, when you look at their faces are very masked. We call it the lizard face, because they look at you, they don't have blinking, they don't, but even more severe, they will not feed themselves when the disease is very, very progressive.
So this is the akinesia.
This is the akinesia, the loss of voluntary movement.
I see. So you physically, your face, your muscle, anything it affects. Why is that? What is missing there?
Because again, this is now what is missing is the dopamine. And what the dopamine is doing is actually shaping the behavioral policy which is carried in the brain. What is the behavioral policy? The behavioral policy is the mapping between the incoming information, between the perception, between the motivation, between your memory, and between the action. And when you lose this mapping, then no action is done. Because all the time what we are doing is that we are trying to do action in order to increase the predicted cumulative reward that you'll get in the future. And this is the role of the basal ganglia, to increase the predicted reward that you'll get in the future. If we lose the dopamine, we don't have this kind of behavioral policy. And having no behavioral policy, namely, sit like this, do no movement, be akinetic.
Now we have to stop doing some movement and talking, because we'll take a break and we'll come back.